Welcome back to another chemistry video. Today's topic is Avogadro's law. So we are still in the gas laws, and this is the third one. We had Boyle's law, Charles' law, and today Avogadro's law. This is spelled A-V-O-G-A-D-R-O, Avogadro. Avogadro, can you say it that way? I have to tell you how to spell it because I always forget because it sounds like avocado, and then I start spelling it like avocado, and then I cannot remember how to spell it. So this is Avogadro's law, but I'm not gonna lie, I do kind of think of him like avocado in my head. So if you want to like picture an avocado here, there you go. Okay, Avogadro's law. All right, this law is very simple. It's useful, but very simple. Here's what it is. I have a balloon. Let's say I take the balloon and I inflate it a little bit. Just a tiny bit, tiny balloon. A very difficult question for you. What happens if you take the balloon and you put more air in the balloon? What's going to happen? Miss, you trying to insult my intelligence? That's kind of stupid. It's going to get bigger. Like that. Doesn't even fit in the camera. Yes, that's right. And so if you put more air in, it gets bigger. If you let some air out, it gets smaller. That's pretty simple, okay? It works with a tire, works with a balloon, works with a whole bunch of things. That is very simply what his law says, except of course we're in chemistry class, and so we need to put this in chemical terms. In chemical terms, if we're saying it gets bigger, what are you changing? What's getting bigger? Good, you should be saying volume. So this is gonna work with volume, space, 3D space. And then when you're talking about a gas and you're saying how much, so you add more air, you add more gas, and the balloon gets bigger. How much? What would we use to measure that in chemistry? Maybe you're saying grams, mass. Well, that does, in a sense, measure how much, but you know, there's a better thing we can use because this is chemistry. Yeah, that would be moles. So Avogadro's law relates volume and moles. Miss, I don't like moles. I know you don't like moles. It's okay. It's fine. You can handle it. Okay? So this is what his law is. It says N1 over V1 is equal to N2 over V2. It looks very similar to Charles' law. It was T1 over V1 equals T2 over V2. But in this case, it's volume and number of moles. N is number of moles. And of course, V is volume. And just like your other ones, 1 means initial. So N1 over V1 is your initial number of moles and volume is equal to N2 over V2. That's your final or ending volume of amount of substances, okay? Volume is typically in liters, could also be in milliliters, and moles is just moles. So that's our law. What would you say, guys? Look at the way it's written. Is that a direct relationship or an indirect relationship? One's on top, one's on bottom. Is it direct or indirect? You should be saying direct, okay? So this is a direct relationship. What does that mean? It means if volume gets bigger, moles would also get bigger. If volume gets smaller, moles also get smaller. Again, that should make sense. Think about your balloon. You put more in, more moles. More air is more moles, okay? Then the volume gets bigger. If you let some air out, then the volume gets smaller. So hopefully the balloon helps you out there. I got a little silly phrase for you. My silly phrase for this one, because I told you it kind of sounds like avocados. So A, N, and V, okay? So I say avocados are not vegetables. I love this fact. And every year I have students get mad at me about this one. Avocados are not vegetables. A and B. You say, Miss, avocados are totally vegetables. No, they're not. Technically speaking, when you take a botany class, a vegetable is something that comes from like a stem or a root or a leaf. A fruit is something that comes from a flower. An avocado comes from a flower, right? A ripened fruit, ripened ovary. And so avocado is a fruit, not a vegetable. Actually, fun facts of the day, there's a lot of things that you think are vegetables that are not vegetables, they're fruits. For instance, like even something like corn. Corn is technically a fruit. Yeah, you can go look that up later. All right, let's try to solve a problem, okay? Now that I've bothered you with that fun fact. How about this one? So it says, if 2.45 moles of argon gas occupies 89.0 liters, what volume will 2.10 moles of argon occupy under the same temperature and pressure? When you're starting with a gas laws problem, you always want to go through and identify what you're given. So the first number you see is 2.45 moles of argon. Moles is, moles. All right, 89.0 liters, so that would be N. Should label that N1. Liters is a unit of, good, should have said volume. What volume? Haha, that's my question. So that means V, I already have a V. Therefore, this is V2, okay? That's my question mark. What volume will 2.10 moles occupy under the same temperature and pressure? So that's moles again. I already had a mole, so that's N2. That's my logic, okay? You already have a moles, then that one's the second one. Again, I said this in yesterday's video, same temperature and pressure. That means you can basically ignore that. It means they're not going to change. And in a gas laws problem, if something does not change, you really can just ignore it. It's not going to enter your math. All right, so now we can say we have N, N1, V1, V2, N2. That sounds like Avogadro's law. So write down your law first. N1 over V1 is equal to N2 over V2. This is the same as with Charles' law. You could actually flip that around and mathematically it's going to give you the same answer. What do I mean? Well, I'm looking for volume, V2. So in this case, it might be easier to put volume on top just for solving sake. It really doesn't matter. You can solve it either way. So if you wanted to, you could write this V1 over N1 is equal to V2 over, whoopsie, N2, as long as you keep the ones on this side and the twos on this side, okay? All right, let's go ahead and plug and chug. So I guess I'll use this one. V1 is 89.0 liters. N1 is 2.45 moles. And V2 is what I'm looking for. We'll leave that as V2. N2 is right here. That's 2.10 moles. If you want to, you can cross multiply to solve, or you can put it into your calculator, or you can just do some algebra. But you want to go ahead and solve this for V2. So please pause the tape here and see what you get. Okay. Everything's got 3 sig figs, so your answer should also have 3 sig figs. I got 76.3, it's volume, so it's gonna match the other volume unit. All right, so that's gonna be liters, 76.3 liters. Now, a quick check to see if this makes sense. If you look at your numbers, guys, essentially, moles is getting smaller. Moles is an amount of gas. So you lost some gas, okay? Some gas, I don't know if it escaped, you let it out or whatever. But you lost some gas, so would you expect volume to get bigger or smaller? Hopefully you're saying smaller, right? Does that make sense with my number? Yes, it does. I started with 89, and now I have a smaller volume of 76. So at least in that sense, it makes sense. Okay, that is Avogadro's law. Hope you enjoyed.